Hi everyone, today I'm going to explain a simple and interesting problem. Floor division. In this problem, we are given two integers called dividend and divisor. Our task is to divide the dividend by the divisor and return only the integer part of the result. We are not allowed to use multiplication, division or modulus operators. And the result should always be truncated towards 0. First of all, we need to know truncation means. If they are given 8.9, it becomes 8. If they are given minus 8.9, it should become minus 8. And the solution must handle positive and negative numbers. The final answer must stay within the integer range. If the result overflows, return the maximum integer value. These problems can be solved by using mat.floor function. Now let us see how it works. Mat.floor of 3.7 gives 3. Like this it works. Next, we came up with a solution called repeated subtraction approach. And the core idea is, first of all, we need to know division can be understood as how many times we subtract the divisor from the dividend. Instead of dividing directly, we subtract the divisor again and again until the remaining value becomes smaller than the divisor. Here, the dividend is 10 and the divisor is 3. So, what we do here is, after the first subtraction, the value becomes 7 and the count is 1. Next, 7 minus 3 gives 4 and the now count becomes 2. This shows 3 has been subtracted 2 times so far. From the remaining 4, we subtract 3 once more. 4 minus 3 gives 1 and the count becomes 3. Now the remaining value is 1, which is smaller than the divisor. So we stop the process here. This means we are able to subtract 3 a total of 3 times from 10. Therefore, the quotient is 3 and the remainder value 1 is the remainder. Let's analyze the time and space complexity analysis. Space complexities. We don't use any extra arrays or any data structure. Here we only used the count variable. So the space complexity of this is constant space complexity. And the time complexity. We subtract the divisor one time per loop. So the time complexity is big O of dividend by divisor. That's it.
Hello, I am Satya. Now let us move from the brute force approach to an optimized solution for the divide to integer problems. The main constraint here is that we are not allowed to use multiplication, division or modulo operation. Why we need an optimized approach? Wait, yeah. Why we need optimized approach? In the brute force method, we subtract the divisor one time per step from the dividend. This approach works, but it is slow for large numbers. Let us take dividend equal to greater than 10 power 8. Then uh, it will leads to TLU, time limit exceeded. So we move to an optimized solution using bit manipulation. Optimized approach used in our code is bit manipulation based floor division. Instead of subtracting the divisor one by one, we subtract the largest possible multiplier of the divisor using bit stuffing. Yeah, bit stuffing allows us to double the divisor quickly, reduce the number of iterations, achieve faster. This bit manipulation approach reduces the time complexity from O of 1 to O of log n. Yeah, this is left shift operator and the value is equal to wait a minute. The value is equal to 21. If we left shift 21 by one time, then we will get 42. It is just similar to 21 into 2 power 1, that is equal to 42. Uh, this is the main idea we used in our code. Uh, Let us take n is equal to 30 and d is equal to 4. 4 left shift 2 equal to 16. If 4 left shift 3, then we get 32. 32 is larger than 30. So we always take uh, the number which is equal to n or less than n. So 16 is better than 32, which satisfies the condition. So answer is equal to 1 left shift 2, which means we can divide the number 30 with 4 times. Now we will reduce n from 30 to 14. Yeah. Now the 4 left shift 1 equal to 8. If 4 left shift 2, then the answer will be 16. 16 is greater than 14. So we didn't take 16. So 4 left shift 1 equal to 8, which is less than 14, our requirement. So answer is equal to 14 plus 2, 6. In this way, at last 4 left shift 0, that equal to 4. Answer is equal to 6 plus 1, 7. So we will stop. N is equal to 6 minus 4. 2. 2 is, we want always n is greater than d. Here n less than d. So we can stop. Let us see, dividend is equal to 30, divisor is equal to 4. The maximum possible number we can achieve using shifting operator is 16. If 4 into 2 cube, 4 left shift 3, then the value is 32. 32 is greater than 30. So here we must take less than 30. So 30 minus 16, remaining part is 14, and our count is 1 left shift 2. The remaining is 14. So 4 into 2, that is equal to 8. 14 minus 4 left shift 1, it is equal to 4 into 2. 14 minus 8, that is equal to 6. 4 into 2 cube, 6 minus, this is equal to 4 into 2 power 0. Yeah. So 30, we can split 30 into these 4 parts by using left shift operator. Yeah. Now the core idea of this optimized approach is based on bit manipulation. Instead of subtracting the divisor one by one, we subtract it in powers of 2, which significantly reduces the number of operations. Yeah. Uh, we subtract every time divisor into 2 power n. This is achieved using the left shift operator. For example, if I take d left shift 1, then it is exactly equal to d into 2. If I do d left shift 2, then it is exactly equal to d into 4. Like so by using this trick, we done this problem. Now how we handle the sign in our code. In the code, we first decide whether the answer should be positive or negative. If dividend and divisor has same sign, then the result always be positive. If they have in different signs, then the result is negative. This ensures correct output for cases like if 8 by minus 3, then the answer is minus 2. 8 minus 8 by 3, the answer is minus 2. If minus 8 by minus 3, then answer is plus 2. So whenever we get different signs of divisor and dividend, the answer is also negative number. Next we will look up in next slide. Overflow handling. It is very important case in our code. First, we handle edge cases. If the dividend and divisor are equal, the answer is 1. If the uh, dividend is integer dot min value, that is minus 2 power 31, and the divisor is minus 1, the result exceeds the integer range. Integer range is 2 power 31 minus 1. But if we get like minus 2 power 31 by minus 1, then the answer is 2 power 31, which is out of range. So at that time we have to uh, handle that. So at that time we just return integer dot max value, which is 2 power 31 minus 1. Now we look up into step by step working of the loop, how the while loop converts. Wait a minute, first we look up into our code. Yeah, first we look up into some example, and then we go to our code. Given divide 10 by 3. Here dividend is 10 and divisor is 3. The largest shift is 3, left shift 1, that equal to 6. Wait a minute, I will explain it then. So here we have to divide 10 with the 3. It is 3. Yeah. Yeah, first we have to calculate 3 left shift 1. This is exactly equal to 3 into 2 power 1. So that is equal to 6. If we do 3 left shift 2, then the answer is 3 into 2 square, which is equal to 2 square for 12. Yeah, 12 is greater than our requirement. So we we add answer in terms of 2 power 1. So 3 into 2 power 1, our answer is 2 power 1, that is 2. And the remaining part we have to calculate is 10 minus 3 left shift 2, that is equal to 4. Now for 4, 3 left shift 1, that equal to 6, which is greater than 4. So 3 left shift 0, 3. 3 is less than 4. So the answer is update. We can update our answer now. 2 plus 2 power 0, that is equal to 3. Now the remaining part is 4 minus 3 left shift 0, that equal to 1. Now 1 is less than 3. So we will stop here. Every time we check one condition, that remaining part is always greater than the divisor. Yeah, this is the example. Now we will look up into our code. I will take two variables, dividend and divisor, in integer data type. Now I'll take answer equal to 0. The answer may exceed the range of integers. So I take answer in long data type. If we know that condition, if dividend double equal to divisor, so for suppose n equal to 3, dividend equal to 3 and divisor equal to 3, the answer is 1. If dividend equal to min value and divisor equal to minus 1, in this case we get 2 power 31, which is integer out of range. So we have to return integer dot max value 2 power 31 minus 1. I'll take one sign variable with initialization 3. Why I take this sign variable? Because I take sign variable to check if the answer is positive or negative. So how I check in if condition, dividend greater than 0 and divisor less than 0. If both have different signs, here also dividend greater than less than 0 and divisor less than 0, greater than 0, then sign the answer should be always false. So I'll at first I'll uh, determine the answer should be which sign. Yeah. Now I'll convert uh, the dividend and divisor into absolute values, which is positive values. Now, I told that we do while condition for every time we check the remaining part always greater than the divisor. So I'll take count equal to 0 while n greater than equal to d left shift count plus 1. I'll increment count. Now I'll add my answer with 1 left shift count. Now the remaining part is n minus d left shift count. In this way I will calculate the answer. At last, if answer greater than integer dot max value, if I got answer that is greater than integer max value, which is 2 power 31 minus 1, and sign equal to true, then the answer is max value. If answer less than min value and sign equal to false, then I have to return answer with the integer min value. If sign is negative, then it returns. If sign is positive, then it returns answer with converting into int data type. If the answer is negative, then we return int negative number, negative answer. Here the time and space complexity. The time complexity here is log n, but at our brute force approach, I got O of n, which leads to time limit exceeded. Here space complexity is O of 1. This is the efficient solution and interview ready constraint safe. So finally, float division removes the decimal part. Brute force uses repeated subtraction, handles negative numbers, handles overflow much faster than brute force. So by using bit manipulation and left shift operator, we are divide two integer effectively without using division, multiplication or modulo operator. This optimized approach is much faster than brute force and works well even for large numbers. Thank you.